All right, so this video is going to talk about saturated and unsaturated fats and how to tell what they are, and then a couple of characteristics of each. So here I've drawn a carbon backbone. Now most lipids are much longer than this. They might be hundreds of carbons long. I'm not drawing all that. I'm just going to draw one. And so this is, if we wrote the formula, C6, let's see, 2, 4, 6, 8, 10, 12, 14. So H14, okay? This is what we call a saturated fat. Saturated means it is full. I always think of a sponge when I think of saturated. A saturated sponge is one that's holding all of the water it can hold. And so if you look at this lipid here, it is holding all of the hydrogens it can hold. Carbon can form 4 bonds. And so if you look at each of these carbons, they have 4 bonds, either with another carbon or with a hydrogen. So there's nowhere to squeeze any more hydrogens in. Okay, so they are full. An unsaturated fat is one in which you have at least one double or triple bond, but potentially more. So, 1, 2, 3. Okay, so we're going to stick with our 6 carbon, and then we're going to put our hydrogens out where we can. But note, this carbon has 1, 2, 3 bonds already, so it can only have one more hydrogen. This carbon has 1, 2, 3, so it can only have one more hydrogen. The rest of these are still good to go. So now when we count our hydrogens, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoops, H12. All right, so what we're seeing is that a 6-carbon backbone should be able to hold 14 hydrogens, but this one can't. It can only hold 12. And so that tells us it is unsaturated. It is not full because of that double bond. All right, a couple of properties about these. When you have all single bonds, and this kind of goes back to chemistry, and the way that electrons don't like to be too close to each other, goes into the whole VSEPR electron configuration, trying to push away from each other and all that. Your saturated molecule is going to be a straight line. Okay, so that is, if it's a saturated, you pretty much have just a straight molecule. When you have a double or triple bond, that is going to cause a bend or a kink in the molecule. And that again goes back to the electrons, the free electrons versus bound electrons, and the bond angles and all that kind of stuff. And so what you're going to see here is you're going to see a bent molecule. Now imagine if these molecules, and I'm going to turn them kind of on their side, if they were to hang out together, how closely could they pack? Well, because they're straight, they can pack really tightly together. So they can get really densely packed. And what this means is they are usually going to be a solid at room temperature. Okay? And so that also means, because we know that solid, liquid, and gas, the phases of matter depend on particle placement. So since they're close together, they're a solid at room temperature. Well, let's say room temperature is 75 degrees Fahrenheit. Then a solid at room temperature means that they have a melting point higher than 75 because they're not melted. So they're going to have a higher melting point. Okay, now let's look down here at our unsaturated. Imagine you have a bunch of unsaturated fats, or imagine that you are mimicking or modeling an unsaturated fat and you stick your arms out to your side. Okay, if your arms are sticking out, you can't get close to other people. So what we're going to see is we're going to see these guys are more spaced out. They can't tightly pack, so they're going to be more loosely packed. This means, again, because they're further apart, that they are liquid at room temperature. And if they, let's say room temperature again is 75 degrees, if they're a liquid at room temperature, then that means that their melting point is below 75 because they're already melted. They're at a liquid. So they have a lower melting point relative to saturated fats. If you don't remember all this right away, don't fret. I still have to think through it. I still have to say, okay, saturated fats, they're straight, so that means they can densely pack, which means they're solids, which means they have a higher melting point because they're still solid at room temperature. So if you have to work through those steps every time you think about a saturated or unsaturated fat, don't worry about it. That's normal. That's okay. If you can memorize it and just remember it, even better. But if you can't, don't worry about it. So that's the difference between saturated and unsaturated fats. I can give the relative melting point low or high. We talked about that, and then talked about the structure, them being straight versus bent. So that is everything for those I can statements. If you have any other questions, let me know, and I hope that helps.